6, and I'll do this a little differently, okay? I'll factor the 5 over 6 out, and I'd get a 66 here, and this indeed gives me 55. Okay? So, following the instructions is telling you to solve by elimination and check algebraically. Alright, next example. And this one's using a graphing utility. Come on, scroll. Here we go. Oh, Layla, I should really get your mouse up on this thing. I'll try and get this done during the break. Okay, use a graphing utility to graph the lines and determine if the system is consistent. And like I told you, consistent means that there is at least one solution. To get the more precise definition, you need to go to page 497 of your book and read that. So we need to graph these things. So before we even graph, we need to put these equations as y equals, okay? I'm going to pause here for a minute. All right, so I'm eating breakfast at the same time, so I had to pause for a minute. Anyway, so what I need to do is I need to isolate the y variable out of here. So I get y is equal to 1/6 4x minus 9. And if I do it out of here, I get y is equal to 1/8 16 over 3x minus 12. And I need to use the n box to graph these two. Okay, let's make sure I'm in the right mode here. Func mode. Okay, go into y equals, clear that, and enter the two equations. So you've got 4x minus 9 divided by 6, and the other one you've got 16x over 3 minus 12 all divided by 8, and graph that. So first line, second line. So let's go take a look at second table. I need to change my table set to say -10 to increment of 1, make this auto and graph that. I have a feeling it's the same line sitting on top of each other. Just to confirm that, let's go take a look at second table and look at all the values. Yeah, sure enough, it looks like y1 and y2 are the same lines. Okay, as you can see, the y values are the same, and therefore you've got an infinite number of solutions. Okay, let's kind of reduce these two equations and see if we get the same line. Okay, so this guy becomes 2 over 3x minus 3 over 2. This guy becomes 2 over 3x minus 4, then minus, yeah. So if you simplify both these equations, you get the same thing, and therefore you've got an infinite number of solutions. Is the system consistent? Yes, it is consistent, because remember, consistent says at least one solution. So you've got an infinite number of solutions, and therefore the system is consistent. Okay, moving on, next example. Oh, mixture problem, nice. How many people taking chemistry love this problem, right? So mixture problem, spend a minute getting it down while I go do my snipping stuff. Not sniffing, snipping. Okay, I'm going to pause here for a minute while you copy this down. Let's start working on it. So let's take a look at, let's draw just a kind of picture to see what it's talking about. You want to make a 10 liter solution, okay? So that's 10 liters from there to there. And you've got two solutions, a 30% solution and a 20% solution and a 50% solution to make a 30% acid solution. So let's say you go and use X liters of the 20% solution. So here's X, as much as X. And then you go and use y to be the 50% solution, so you get this much is y. Okay, notice that these are all in liters, okay? This is all in liters. So this guy, the second one is 50%. The first one was 20%. Okay? And notice that x and y are in liters, okay? You can see it right there. And so here's your first equation, x plus y equals 10. Okay? Because the total amount of solution you want is 10 liters right there. So then the next thing to do is do what's called the acid amount equation. Okay? So from the 20% solution here, let me get the right color back here. From the 20% solution here, this is the amount of acid I will have. Right, because it's 20% of x. The 50% solution comes from y liters of it, and therefore you get this much acid from the y liters, which is a 50% solution. The final result should be a 30% solution. Okay, so out of the 10 liters, 30% of it is acid, so there's that part there. Okay. 30% is 0.3 of 10 liters is 3. So you've got two equations here now, okay? And the equations are x plus y equals 10, and then you got this funky fractional one. But that's okay. We can do numbers. That's 3. What I would like to do is I would like to times this by 10, okay? So that I get rid of the decimal numbers, so I get 2x plus 5y equals 30, and we need to solve this. And let's say we go to solve this algebraically. What I'm going to do is I'm going to times, so I'm going to call this my first equation, this my second equation. I'm going to times my first equation by a negative 2, so I get negative 2x minus 2y equals negative 20. That's my third equation. And then I'm going to add the last two equations, 2 and 3. I'm going to add these guys. So then this cancels. This gives me 3y equals 10. And so y is equal to 10 over 3 liters. Okay. So I need 10 over 3 liters of the 50% solution. And to get x, I'm going to go and plug y in here. And I get x equals 10 minus 10 over 3, which is going to be 20 over 3 liters. Okay. So don't leave your answers like this. I want the answers to be written as need 20 over 3 liters of 20% solution and need 10 over 3 liters of 50% solution. And that's how you do a mixture problem. I don't think it's too hard. I don't know why chemistry guys just totally freak out in this one. Anyway, I think, let's see, I think that may well be the last example in 7.2. Oh, well, I guess I suggested using a graphing method, but we used algebraic method. All right, and I'm done for 7.2.